There are over 10 lakhs organic compounds at this moment, and still the number is counting on. Unbelievable, isn't it? So versatile, so useful these organic compounds are. And naming is not that difficult if we follow IUPAC nomenclature of organic compounds thoroughly by imbibing the system of rule that IUPAC follows. What is IUPAC? International Union of Pure and Applied Chemistry. Now this organization has set up certain rules, like we do have a name. Now when we have a name, we have a surname, the first name, middle name and the surname. In some cases quite a long name. In India, especially the South Indians, have a lot of middle names in between the first and the surname. Similarly, it is a first name and the last name. So after this session, you will be enjoying naming organic compounds like as we have our name simply. So to make life simple, let's start with some some compounds first. Then we will discuss about what rule is applied here. That will be quite convenient for us. Welcome to DP 360 degree once again here. Now see, this is quite simple here. CH, we know carbon has 4 bonds. This is the basic information you will always keep in mind. As in the previous classes also, I have told you, but I would like to recap from the scratch because many people have requested they found it very useful but a little advanced level. So today I am starting from the scratch again, keeping all your requests. Now here, for single bond compounds of hydrocarbons, which has only single bond, means here these are called as alkane. They fall into the category of alkane. Remember, if there is no other functional groups attached to it. AN is the main alphabet. Now here, if there are double bond present in the organic compound, it is an alkene. Small change, it will become E and E. And if triple bond is present in the organic compounds, it's an alkyne. Alkyne. Now we'll simply check here. There are all single bond, so it falls into the saturated hydrocarbon category. It's a member of saturated hydrocarbon category of alkane. Now here we'll start counting the long continuous chain of carbon atoms. Now here we can start from this end, we can start from the other end also. 1, 2, 3, 4, 5. Then also we'll do the reverse counting. There is a reason behind it. I will explain you with the passage of time. 3, 4, 5. So what do we see in the longest carbon chain? There are 5 carbons attached to it. 5 for pent, and the name is pent for 5. And we'll add here ANE. To distinguish, I am using NE represents this is an alkane hydrocarbon and it has single bond. Now here one thing, for one carbon atom, when carbon atom is 1, it is called as meth. The prefix we will use meth. For 2 it's eth, ETH. 3 for prop. 4 for neut. 5 pent. 6 hex. 7 hept. 8 oct, it is called as oct, OCT. 9 non. 10 dec. 11 undec, UNDC. 12 dodec. 13 tridac, 14 tetradac, 15 pentadac, like that. the list goes on. I think the first 10 are of very important to us. So the first 10 we should remember always. One is meth. Here we have 1, 2, 3, 4, 5. That's why it falls into this. 5 is pent here. Can you remember here? Pent. P-E-N-T. Where is it? P-N-T. And since all of these CH bond or CC bonds, all of them are single bonds, and hence they are saturated alkane compounds. One example is, again the numbering, I'll start 1, 2, 3, 4, 5, 6. Fine. Now 6, I can start numbering from here also. 1, 2, 3, 4, 5, 6. So in the longest chain is, so 6 single bond. It's case of hex, HEX, ANE. It need to be followed as a suffix here. N is the suffix to signify the family of the organic compounds to which belongs to alkane. So quite comfortable here. Now this one, double bond and triple bond, will take a little later. So we'll give some examples here. Now suppose one more thing, some of the substituents you need to know. These are the groups which are attached to the side chain. For example, chloro, bromo, fluoro. It has your iodo. All these are chloro. This is called as chloro. This is called as bromo, bromine if it is attached in the side. Fluoro, I for iodine, iodo, it will become iod. Okay. And CS3 stands for, this is an alkyl group, and this is an alkyl group. Alkyl. CS3 stands for methyl. Meth, if you remember, for one, meth, here one carbon, that's why methyl alkyl group. For example, C2H5, it will be called as ethyl group. C3H7 stands for propyl, and similarly it goes on. YL will use YL to signify. This will be used again and again. That's why to keep a note, you need to be knowing at least. Some more major functional groups we'll be discussing very soon. Now your pentane. Let's suppose if I add chlorine here, what will be its name now? What will be its name now? Say CS2, CS3, CS2, CS2, 3 bonds, 1 more H and 3. All of these are single bond. Definitely it's an alkane beyond any doubt. We ignore Cl here. If you look here, there are 5. 1, 2, 3, 4, 5. Generally, if I ask you, some of you, if not all, some of you will name it as 4-chloro, because any substituent group is attached as an here substituent. So as a prefix here, chlorine will be added as a prefix. 4 dash, 4 hyphen, chloro. Chlorine will become chloro. Look here, chloro. So chloro, 4-chloro. Then 1, 2, 3, 4, 5. 5 is your pentane. Pentane. But my dear, this is wrong. This is wrong. Now 5. This is 1, 2, 3, 4, 5. Now here, if I count from right to left here, this side, chlorine will get the lowest number in compare here. In the first from left to right, it gets a number 4. But when we name there, this carbon has been assigned 2. 2 is the lowest, so we'll take the lowest value. So chlorine is attached to the second carbon here. So if I write 2-chloro, then 5, obviously pentane. This is the correct one. This is wrong. That means two rules we are following now. We have followed so far. One is we have to identify the longest possible carbon chain, continuous carbon chain, number one. Second thing, we have to find the location of the substituent which is present along the side chain in the carbon atom. We have to identify that also. Now we have to assign the lowest possible value to the carbon atom to which that particular substituent is attached. Here in this case it's chlorine. So we have to be little flexible here in terms of naming. Now let's take another example, quite a little larger, CC. Now here we have chloro, Dr. Now here we can't start from here because these functional groups will then have the carbon to which these functional groups are attached will be getting a higher number. So rather than we will be starting the numbering from the last one, 1, 2, 3, 4, 5, 6, rather than 1, 2, 3, 4, 5, 6. So lowest possible value will assign to that carbon number to which these substituents are attached here. Now here both these halo groups are attached to 2 and 3 respectively. Here we have to see the alphabetical order here. B comes first before C. The first is chlorine is C and B comes first. So alphabetical order, it will be 2 bromo hyphen 3 chloro 1, 2, 3, 4, 5, 6. 6 are there. 6 means, and no double bond and triple bond obviously. So it's a case of hexane. I'm just use the red color to distinguish as this is the suffix here. These are the prefixes which I used before. Two substituent group here, bromine and chlorine. So they are used as a substituent. So the main substituent are always used as prefix. This is a prefix and this is a suffix. Yeah, in this case. Now some more example. Now here we have an example. Let's try to name this one. Now we have to identify the substituent here. Now 3 substituent, 1, 2 and 3. If I start naming from this side, 1, 2, 3, add carbon third, we find the first substituent, that is bromo. But if I start numbering the carbon atoms from the left towards the right, 1 and 2, add carbon 2. So 2 is the lowest number and the substituent should get, the carbon to which the substituent are attached should get the lowest value. So we have to start numbering from this side, 1, 2, 3, 4, 5. In the main chain, 5, and definitely it's a case of alkane, single bonds. All of them are single bonds. Now here, bromo will come first. Why? Alphabetical order here. Chlorine, C, A, B, C, D, that's called as alphabetical order here. So B comes first. So it will be 3 bromo, again hyphen, then at 2 there are 2 groups, so 2, 2, then we use di is the word we'll use here, prefix for chlorine, because 2 dichloro, and the main is 1, 2, 3, 4, 5 pentane. Parent compound is an alkyl and these are the suffix here. So at second carbon there are 2 chloro, that's why dichloro, and third bromo. It's following that alphabetical order. So far 3 rules have been used, have used so far. Let's take some more examples here. Now let me tell you one very interesting examples. you know, this is called as this is the expanded formula, structural formula. It can be written as CS3. Similarly here, if H and CSE, hydrogen, 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 you know, this is an alkyl group, this is an methyl, and so this is your ethyl C2H5, ethyl group. Fine. Similarly, propyl, butyl, the list goes on. Let's take another compound and try to name it. Now, if you really want to enjoy on a serious note here, you have to take pen and paper, try to name it along with me. Then the pace we match together and the learning will be absolutely delightful. Now C2H5. Let's say, see, I will use this shortened formula CS2, CS3 rather, CH2, one here. Then say suppose ethyl group I am attaching here, CS2, CS2, ethyl group, and CH3. What will be the name of it? Generally, without thinking twice, most of you will start numbering because these are the additional substituents here. So in any case, if I start naming from this side or that side, lowest number will be assigned 2. So it will be 1, 2, 3, 4, 5, and you know by this time you are aware. So 2 at second position and at fourth position. These ethyl groups are attached. So according to most of you, it will be 2, 4 diethyl, and since the longest parent chain consists of 1, 2, 3, 4, 5, it will be pentane. And yeah, you have gone bizarre. The answer is absolutely wrong. Why? We have to look carefully here. This is wrong. This is wrong. This is right, actually the structure is right, but the naming is wrong. Now here we have to be a little careful. You have to see exactly, have we counted the longest chain here? Let's try. Now ethyl, if I open it up, it becomes CS3, CS2, ethyl we know, CS2 and CS3 we can write. So it becomes CS2 and CS3. This is your ethyl group. CH2, again CH2, we have CS2, this one I'm expanding here, CH3. This is the ethyl group here, both these ethyl groups, and of course this CS3. Now if you look carefully, of course you get 5 here if you look here, but if you start counting from here, 1, 2, 3, 4, 5, 6 and 7, my god, 7 continuous chain of carbon atoms here. And a third one, methyl group is, this is methyl group of course, and this is another substituent here at the fifth, that is this again the second. So dimethyl case here of course. Now as all of these are, there is no double bond or triple bond, it's a case of alkane. Heptane, 7 is the longest chain, no other chain can match that value. So the parent chain, the longest chain is 7 here, heptane definitely, but at third and fifth position, so it will be 3, 5, yes, 1 for 2 for di, 2 for di, 3 for tri, 4 for tetra. So 3, 5 di methyl heptane. It will be 2, 4 dimethyl, just a second, heptane. So need to be a little careful. This, when we expand, we get. So that means one thing we have learned, that we should not only think horizontally to come up with the longest chain of continuous carbon atom. Rather than we need to be careful, it may be in a zigzag fashion to find out the longest chain. Now, I'll tell you the skeletal structure, how to draw, because that will be useful to save time when we try to name a large number of organic compounds after this. So 3,5-dimethyl heptane. Let's recap the structural formulas, then the expanded formulas and skeletal formula. Now the structural formula, of course, you know, let's take one example here, C4H10. Now this can be, you know, carbon bonded together. This is a structural formula. With single bond, alkane, general formula CnH2n plus 2 falls in the category of alkane. This is a butane. Now, life becomes a little difficult, it consumes time if we take a larger size of compound. For example, say suppose C9, I know the formula, it will be double plus 2, that is 18 plus 2, 20. Now we can take C, 3 to 5, 6, 7, 8 and 9. You have to write hydrogen, hydrogen, top and below. 4 bonds, we need to be careful. Fine. Numbering, you know, 9's away, 1, 2, 3, 4, 5, 6, 7, 8, 9. No substituent here, so no props here. But to make life easy, we can draw this is 1, this is 2, 3, 4, 5, 6, 7, 8 and 9. We take skeletal structure to save more time. Say suppose first one, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see, 5, 6, 7, 8 and 9. This is the skeletal structure. Skeletal structure for your nonene. It represents nonene, the skeletal structure. Now it saves time here. It saves time in forming. And every dot, the terminal point, the starting point and the ending point represents C with 3, exactly this one. 3 hydrogen here. Here CH2, here it's CH2, CH2, CH2. If no substituent are present here, and all of them are single bonds. The initially CH3, CH3, and rest all the points are, the turning points are CH2. Fine. Now let's try another one to be a little comfortable here. Let's change here. Say suppose I add at 5th one chlorine, at 6th one bromine, and at say suppose not 6th, then it will be say suppose chlorine. So it will be then counted as the substituent should get a lowest value. We will not count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll take counting from that side, because here we remember the substituent should get priority by assigning them the lowest possible number. From this side, it's quite far away. The starting carbon will be 5th, which is quite large compared to the second one. So from that side, we cover the numbering better. Now, how do we represent here? Now, it becomes my 1. This is 2, 3 now, 4, 5, this is 6, 7, 8 and 9. In any case, it's 9 from right to left or left to right. Now here, chlorine comes at the second position. Here, Cl. Just write Cl here. Now, bromine at, from this point, it's 4th position. Bromine. And 5th position, this is, and right here 5. This is chlorine. the bottom. It means the same thing. So to draw the skeletal structure, it's really time saving, and we need to have a, but before we approach for skeletal structure, we need to have a solid understanding about the things. Let me recap once again this skeletal structure. Each starting point represents CS3. We can denote it by double bonds also. Now if you open it up, it becomes the same structure, the normal one for non-N here. We can try for any other. I hope you're quite comfortable. Now I need space here. Now let's try for alkene and alkyl. We include the double bond and triple bond here. C, double bond and C here. If I start numbering from here, 1, 2, 3, 4, 5. There are 5 here. So we know double bond means alkene. They fall into the category of alkene. And also we can 1, 2, 3, 4, 5. So it's a case of definitely pentene. But here, if I start counting from here, not a double bond, the carbon which is attached to the double bond, it should have the lowest value that will be counted here to signify the double bond here. Now if I start from here, the first one is carbon 3, but if I count from right to left, then 1, 2, 3. At second position, this carbon has this double bond attached first. So it will be, I have to number it from this. We have to discard this numbering here. So need to be little flexible. Means here double bond, the carbon to which the double bond is attached should be assigned the lowest possible value while following the longest chain. Now of course this is pentene, but this will be pent dash 2 in. Pent 2 in. Now here is one more hydrocarbon. Let's name it. Of course, from any end, it's a middle one. Say 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now let me explain here. It's not only a case of, it's a substituent with further substituent. Means like this is a case of branching and further sub branching here. Now this is a group here. The longest chain will be attached with that carbon here. So this is the carbon which is attached to the fifth carbon of the main pairing chain here. So this carbon will be assigned 1 here. Then we have to follow a longest chain from this. If I go here 1, 2, 1, 2, no. If I go this side 2 and 3, yes. So here I get the longest substituent here. This is your 1, 2, 3 propyl here. But here at first position of propyl, again there is further substitution to methyl group. These are the methyl groups attached here. Methyl. Now here, let me explain once again here. This is the main substituent here, but again in this substituent there are 2 more substituents attached to that substituent. It's a case of branching as well as further sub branching. In those cases, this is a case of called as complex substituent. This type of substituents are called as complex substituent. How they are represented? They are first always put in bracket. Inside the bracket means it's a complex substituent. Now the complex substituent is at the 5th carbon here. Is at the 5th of the main carbon. So I will write 5 dash. Now there the position of the methyl group in here. So it will become at 1, 1. Because there are 2 methyl groups here, 1, 1 dimethyl, yes, 1, 1 dimethyl, then the propyl, bracket close, and the main name nonene is nonene here. Main name is nonene here. Let's take, have you understood? Let's change the same formula to a little by rubbing this. Please jot it down. In pause and always go back. Now, say suppose here I'm attaching one chlorine, and here I'm attaching one further chlorine here. Further chlorine here. Now numbering this one 1, 2, 3, 4, 5, 6, 7. We have to change the numbering here now, because this should be also assigned the lowest possible number, the substituent. The basic fundamental rule we should not forget. Yeah, we have to be always keep on thinking. So now the numbering also changes. 1, 2, 3, 4. Now this one is 5, 6, 7, 8 and 9. But for this the numbering remains same. For the complex substituent, it do not changes. It do not changes. Now what is the name now? Now always first the complex substituent will be set as the prefix inside the bracket. But first the carbon number to which the complex substituent is attached will be denoted by the number. This critical number is 5 here. So it will be 5 dash bracket start to represent the complex substituent, and then the substituent are further 1, 1 dimethyl, then we have obviously propyl, close, then dash 2 and 3, 2, 3 dichloro, long distance of course is nonene, so the parent will be nonene. I am using different color so that to make you more convenient. Nonene. Interesting. Now it's getting a little clumsy, so let me rub it. First of all, let me introduce some of the important functional group with small examples to make you absolutely comfortable. First with COOH, you should get the top priority. It should be OIC is the like one example. OIC acid is called as OIC, and acid basically carboxylic acids are called as OIC. We'll add to that main parent chain. CHO stands for, yes, most of you know, aldehyde group. It's called as aldehyde. The acid basically aldehyde, and they are represented as Al at the end suffix. This is ketone, and they are represented as ONE, not one. Of course, we have alcohol also, OH, so this is alcohol. It is called as, OL, and goes on. Let's take one example. Let me start with alcohol here. So suppose 4, and then OH, of course, very simple. It will be the carbon attached to the functional group. Main functional group now should get priority number 1, 1, 2, 3, 4 and 5. So it is attached as 1, and 1 we can ignore here. We can straightway write the name here. 5 means it can be written as pentan -1 all, or simply if it's not written at the corner one, we can write pentanol. Pentanol. Now another example, if suppose at these 4 this chlorine is attached, here one bromine is attached, then what will be the name here? What will be the name? It will be 3-bromo 4-chloro, C small, it has to be small, C-chloro, 1, 2, 3, 4, 5. Chloro, it's 5 is there, so pentanol. Pentanol. Or here, pentane, the position of 1 and all. And CS3CO, CS3, and say CS3, CS2, CHO. This is of course an aldehyde, and this is a case of, you have to recognize first, you should be in a position to identify whether it's an aldehyde or not. So this is an aldehyde and this is an ketone. You see the general formula of ketone here. This is ketone, O-N-E. It will be named here. Now, one important difference between aldehyde and ketone is that aldehyde, this functional group, always appears at the end of the main chain of carbon compounds of that carbon chain, whereas ketone somewhere in the middle, but never at any of the end, at the beginning or at the end. It should not be present. So ketones are not present. This ketone group are never present on the terminal carbons, either from the beginning or at the end. That means, somewhere in the middle. That means one thing, there should be at least one carbon atom on either side of the main ketone group, whereas this can be the terminal portion of the main organic compound. That's important difference here. So it will be named also. This carbon we have to include here, CHO, 1, 2 and 3. If we open it, how does it look? CS2, C, somewhere you write double bond O, H, CHO. This carbon we also need to include while naming. We cannot exclude that. So it gets 1, 2 and 3. So it will be your, since it's an aldehyde, propanol, or more propan 1Al. At one position it is, the first carbon is there, but here it will be named as, if you see continuous chain of, it's called as propanol. Propan 1, 2, 3, propanol. This aldehyde is the name propanol. This ketone, correction, this ketone, the name is propanol. If you want, I can give you one more example of ketone. You can have CS3, C double bond O, CS2, CS3. The common name will be ethyl methyl ketone. Ethyl, this is ethyl group. This is a methyl group. Methyl group. So, and alphabetical order if we follow, ethyl, E comes first, then M. So it will be called as ethyl, methyl, and ketone, of course, this is. But the proper name will be 1, 2, 3, 4. It will be butanol. butanol, butan and ON, butanol. It will be butanol. Getting quite comfortable. Now here, COOH, if you know, say suppose COOH, H and H and H, 1 and 2, so it will be ethanoic acid. 1 and 2, there are 2, so it will be ethanoic acid. Now this priority list is very important here. Let's elaborate through one example here on the board. Four, 5. Let's convert it to COH, and let's have, at the second we have OH. Now what will be the name of it? What will be the name of the functional group here? Functional group is your obviously oic acid here, and there are 2 functional group attached here. But on the priority list, it's COOH. So the parent name will be known as that of acid. It will be recognized as acid. Main is your acid, whereas this will act as the prefix here. So here on the priority list, if a particular functional group finds a higher value here, high position, so it will be considered along as a suffix there, and whereas the other one will get the prefix here. So 1, 2, 3, 4, 5, 6, suppose. So it will be 2. Now this will be called as hydroxy, not alcohol. Hydroxy, what it stands for. So 2 hydroxy, 1, 2, 3, 4, 5, 6. This 6 for hexanoic OIC I have to add. So how acid is formed? From alkane, E will be deducted and OIC for this one will be added here. So it becomes alkanoic. The general terminology for naming the acid, hexanoic acid. Now if we change the functional group further, now say suppose we have again say suppose OH, what will be the name of it? Very easy, 1, 2, 3, 4, 5, 6. So 2, 3 dihydroxy, 6 means hexanoic acid, hexanoic acid. Now, for example, another example, C OH, it can't be. It will be if I attach here, it can't have a double bond here. See, double bond, single bond, it's fine. OH, which I can attach here, and one more H here, and then we have, say for example, CHO. In that case, between this priority list we have to check here. Again, CHO appears above this, here. So it will be CHO is the main functional group here. So here we have to count 1, 2, 3, 4, 5. It will be 2 hydroxy, yes, 1, 5 is there, pentanol, PNTANAL. Now please allow me to say bye to you. Let me conclude this session. We'll meet in a new session part 2 of the same nomenclature will continue. Take care.